Hi everyone, just a bit of an update here. So I've kind of been a bit AWOL for a while, been on the down low. Work's been pretty busy, and I've been doing a maths course, so I haven't really had much time to record videos. But hopefully I'm back now, and I'm going to be recording a lot more videos to upload. Sorry for the microphone quality, I've got a temporary microphone. But the main news of today is, well, one, I received my HTC Vive, so I've been trying that out. It's really cool. Definitely a step up from DK2. And the second thing is that Oculus have released their own customized version of the engine with their own custom renderer built in. So this is an offshoot of 4.11, and it adds this extra renderer. So instead of a deferred renderer, which is the standard in the engine, it implements a forward renderer. The difference being that a deferred renderer renders to lots of off-screen targets and then composites the result together, whereas a forward renderer just renders everything to the screen at once. And this way, if you're rendering quite simple content for VR, then it's a lot quicker and you can shave a lot of frames per second. So please just go to the developer oculus.com website and you'll see this post. So I've gone along to GitHub, I've downloaded the repository and compiled it, and here we go. This is the build of the engine, and there's no difference from the 4.11 build that you get from the launcher, apart from it's got this new renderer built in. So let's play this. I've got a template sort of real-time strategy VR camera prototype here, so this is what I'll be showing. So by default, this is what we have. We have the standard renderer, and we're getting 45 frames per second, like 25 milliseconds. Not great, because the panel of the HTC Vive is 90 Hz, 90 frames per second. So what's happening here is that the game isn't quite reaching it. You know, we can come around here, get closer, and we can look down, get near, look around, look at the trees. So the engine isn't keeping up with the panels, so it's dropping down to half of that, 45 frames per second. But if we now implement the new renderer with the console variable, use clustered forward and pass it 1, it'll switch that on, and now we jump right back up to 90 frames per second, which is really cool. So we can get that nice and smooth. Yeah, look at that nice tree. So this is my RTS camera prototype. So what happens is it kind of mimics a StarCraft 2 style navigation system, where you can use the middle mouse button and drag. So I'm dragging the mouse up and down here, and that moves the camera back and forward, as well as, you know, being able to turn left and right. Now if I turn the camera 90 degrees to the right, and then I grab the mouse and go up and down, then that still behaves like that. So what's happening is, let me just exit out and go to the blueprint. I've got a player controller which takes in the mouse. This is an input axis, and what it does is it figures out if the middle mouse is dragging, and if it is, it's going to add the actor local offset. And this is what the camera is attached to. The camera is going to be moving along with this actor. Now, the way that this works is it takes the forward vector of the HMD. So this is just getting the rotation of the HMD, getting the forward vector, zeroing out the Z, because you only want the X and Y, like sort of 2D kind of translation, and then that's going to be the forward vector. So then, what's happening there is, once that moves, that forward vector, the mouse is going to basically move in that direction. So if I just play that again, you can see that even as if I'm going to drag forward, even as we turn, we go in a kind of an arc, and that works side to side as well, because we have the right vector implemented as well. So we can look around and drag side to side, and it's all very nice and smooth, all very nice and easy. So, you know, you can just get down if you want and go forward, back and forward. It's quite nice to control with the mouse, because you're not having to move the rotation of your hands. You're just you're just controlling like you would normally, and the only thing you're moving is your neck. So hopefully I'll do a bit more of an in-depth video on how to set this up soon. And then we've got some extra stuff for like when we have a toggle between VR mode and non-VR mode. So if I was to play and then hit T, then we can go back to a standard RTS, and if I hit T again, then we go back into the VR mode. And we also have some basic things such as on begin play, we detect if we're in VR mode. So if we started it from VR preview or from the executable, then we can detect if that's right, and we can forward that to the pawn. And in the pawn, we basically on the begin play we detected that variable that we just set, and we are attaching the camera to an offset in space that we can control. And if it's not in VR mode, then we attach it to a spring arm, which if we just look at the hierarchy here, we just have a sphere with a spring arm. So this is how we're setting up our default kind of viewpoint, which is this one. So this is the spring arm camera, and then ideally we'd be able to kind of just seamlessly go in and out if we want to. Well, you probably wouldn't do that, but it gives you the option. But anyway, so hopefully I'll be going over a lot of the sort of HMD controls. There's a really good YouTube series from a guy called Mitch's VR Lab, and that was really helpful for me to understand how a lot of this stuff works. So please Google him and check him out. And yeah, if you guys have any requests for tutorials, let me know, and I'll try and get to them soon. But this is what I'm working on right now, this prototype. So yeah, thanks for watching, and I'll speak to you soon. Bye.